Hi, this video is about the ways in which we can graph data for our IB subjects. So let's take a look at the principle. We know already how a frequency table works. Remember that over here, this means that there are 30 ones. So imagine a list, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 30 of them. And then you have 27 twos and then 14 threes. And we just present it as a frequency table, which you should have seen in the previous video. Now, what are we going to do when we're graphing them? We're going to show it in a way that's easier to read. This, for example, is going to be one of the types of graphs we're going to learn. Here is a summary. The types of graphs will be the histogram, which looks like this, the cumulative frequency graph, which kind of looks like this, and the box and whiskers plot, which looks like this. And actually, currently, the three of these graphs represent the same data in just a different form of representation. Let's look at histograms first. So histograms, well, they look like bar charts. Now the height of each bar is telling you how many there are, how many of those elements there are. And the width of each bar is telling you the interval. That's important. Look at this frequency table over here. So from 0 to 10, I've got 4. From 10 to 20, I got 1. From 20 to 30, I've got 5. From 30 to 40, I've got 1. From 40 to 50, I've got 3. Therefore, I can draw the histogram. This is what it will look like. It's common, well, not that common, but sometimes they ask you to draw a histogram from a frequency table, or they give you a histogram and they ask you to complete a table using the data that appears in the histogram. Cumulative frequency curves are, they basically rely on the concept, of cumulative frequencies. Let's understand what a cumulative frequency is. So for example, if I have the numbers, these intervals over here, from 0 to 5 there's 13, from 5 to 10 there's 28, from 10 to 15 there's 17, I can do the cumulative frequencies. So from 0 to 5 there's 13. And what I have here is actually how much there is from 0 to 10. All I have to do is add 28 and 13. Here I have how many elements there are from 0 to 15, which really is just 17 plus 28 plus 13. And over here I have all the elements there are from 0 to 20, which actually is all of the elements. And they appear over here. I could also have a cumulative frequency. They don't have to be in intervals, although these are the ones that we will use for cumulative frequency curves. But they could also appear in more standard frequency tables. So let's take a look at a cumulative frequency curve. What does it look like? Well, if you had to draw one, you draw the axis, make sure to be careful with the axis. You draw points. For the x-coordinates, you draw the highest point of the interval, and for the y-coordinate, the cumulative frequency, and then you connect the dots with a smooth curve. That's very important. So for example, if I have the weights of apples distributed here from 0 to 10, 10 to 20, how many there are, 4, 1, 5, 1, 3, I can draw here, I can calculate the cumulative frequencies, as we explained in the previous slide. And this would be what the graph would look like. Now, when you draw them, be careful to make sure that this makes sense. Because often, well, it's easy to not draw them perfectly well at the beginning and then regret it because you have to erase. That's why it's important that you draw graphs with a pencil, which is allowed in exams. To draw a box and whiskers plot, it looks a little bit different. Well, you have to use the table, find the maximum minimum value, the median, the lower and upper quartile. So suppose I have this table over here. Well, I have to find the minimum, quartile 1, median, quartile 3, and the maximum. What do? Well, I have from 1 to 7, I'm going to draw a bar, approximately from 0 to 8. At 1, I'm going to draw a vertical bar, and another one at 2, and another one at 4, and another one at 6, and another one at 7, and then I'm going to join them to make the box and whiskers shape. There you go. And that's how you draw a box and whiskers graph. Here's an interesting example. You have to think about how cumulative frequency graphs really are behaving. Take this histogram. Now look at how big the boxes are in the histogram. You see from 0 to 10, it's quite a big box. From 10 to 20, it's actually very short. 30 to 40 is short, 20 to 30 is very big, etc. Well, look at the increments. Think about the increments in the cumulative frequency curve. Well, you see from 0 to 10, it's going to be quite a big increment. So also from 20 to 30, but the increment from 10 to 20 is very small. So you can see now how these two are actually the same. Here's another important skill you need to learn about cumulative frequency graphs. Here's an example. So a very typical thing is that they ask you to estimate the median. So you see there's 120 elements. That means that the value that's in the middle, if I put them all in order, it's going to be around position 60. Now this is an estimation of the median, very important. So the middle element is going to be here. Let's find out how much it measures. You can draw a line all the way here and then just go down to figure out what its value is. And its value would be approximately 31. To estimate the quartiles, well, Q1 will be at position 30. Q3 will be at position 90. So you repeat the process. And there you have your estimations. About 23 and around 37. Most of the time in exams, these are going to be a lot more accurate. It'll be very easy to see which number it is precisely. Here's an exam exercise, an idea. Suppose they give you these graphs here and they ask you to link each box and whiskers chart with the appropriate cumulative frequency graph. So which one of these represents the same data as the ones that appear here? Now remember, box and whiskers are always showing what the distribution is like. So from here to here, that's actually from the minimum to the lower quartile. From here to here, that's from the lower quartile to the median. From here all the way to here, that's from the median to the upper quartile. And from here to here, that's from the upper quartile to the maximum. Now, if you think about it, it's very important, but if you think about it, there's 25% of the population fits here, and 25% of the population fits here, and 25% here, and 25% here. That means that from 10 to 20, in this graph over here, from 10 to 20, that's where all of the population is appearing. That's going to be this graph over here. Now, I just realized there's a mistake over here, because this should have started at 0, not 10. Hope you forgive me for this one. But just understand just how most of the population happens to happen at the lower intervals. So my cumulative frequency graph must be growing a lot at the beginning. And then, well, a bit more slowly. This one over here has all of the population growth at the end of the interval. So it probably corresponds with this one. And this one here, well, it's all shared out. So it probably corresponds more with this one. You can see how this works. It's important to have a bit of a vision of how these graphs relate. Here's another idea. Suppose they give you a histogram like this, and they ask you to calculate the mean and the standard deviation. It's actually quite straightforward. So remember, you have to calculate the midpoints. You can build a frequency table, and once you have the midpoints calculated and the frequencies, all you have to do is put it in your calculator and obtain the results. Now, this is a part of the syllabus which very, very, very rarely, or actually I can't think of a case that appears in exams. So outliers, just understand the principle. Look at these three sets of data here. What's funny about them? Well, look at this one here. All of the numbers are between 1 and 10, except for 587. If I calculate the mean, I get 62.6. That's totally way weird, right? Because it's very different from the median. You can tell immediately just how different it is from the median. Over here, however, things are a lot more similar. And over here, well, this is a very exaggerated case, but the mean is 171. That's huge. So essentially, the idea is that sometimes when I have some piece of data, there's one element or a couple of elements that are so much bigger than the rest that they're just called outliers. And they severely affect the mean, but they don't affect the median and the mode. Because you see, the median and the mode are very well behaved over here. And that's why sometimes it's good to compare always the these three indicators. So keep an eye open for outliers. Remember, look at the mean, look at the median, check out if there's something very funny going on or not. What happens with outliers when you represent something? Suppose I'm representing this data set. You see, it's 120 is really much larger than the other ones. Of course, if I draw a box and whiskers, well, it's going to look horrible. It's terrible. I can't see anything. This is very non-useful. So 220 is an outlier of this data set. So there's a way to represent it so that the graph doesn't look that stupid. You just make a little note over here, like just, I think you put a little star and you say 220 is around here. It's an approximate way to represent the outlier. To determine what an outlier is and whether you actually do have an outlier or not, this is what you should do. You calculate the interquartile range, that's Q3 minus Q1, multiplied times 1.5, and take that value and add it, subtract it to quartile 3, and add it to quartile, add it to quartile 3, that gives you 8, and subtract it to quartile 1, which gives you 0. So basically any number that's lower than 0 or bigger than 8 would be considered an outlier over here. And that's, why 220 is considered an outlier. Note that sometimes numbers can be outliers very quickly. Just a reminder, they very, very rarely ever ask you a question about outliers, but you should know about it because it does appear in the syllabus. Thank you for watching. I'll see you next time. Goodbye.